Hi, you have just completed, I'm assuming the try it and example one in the try it in Envision. And now you are in your textbook and you can see this is from the video that was in Envision. If you didn't already watch that, I would say go back and find that assignment. It was 8-7, example one and try it. And here is the place, and you probably just watched the video of me going over the answer for this here on page 460. So I'm going to go over one more page here, hoping that it opens. All right, good. So here's example two. And what I want to show you is that when you make a cross section, when you slice a three-dimensional object, if you slice it so that it is going horizontally or parallel to its base, um, like you see here in this one here, then the shape it makes is always the same shape as its base. When you slice an object and you slice it vertically, then that's going to be the same shape as the face that it's next to, so rather than the base. So that's why when you take this pyramid and you slice it parallel to its base, it gives you a square as its cross section. But when you take this pyramid and you slice it vertically, you get a triangle. So assuming that your cross sections are sliced and they're not diagonal, then it will be really easy to figure out what the cross section would be, because if it is parallel to the base, then it's the same shape as the base, and if it's cut vertically, it's the same as the face on the side there. So what I'm going to do now is try one of these examples here, and I would like for you to write that in your book. So here I am for number 6 on page 463, and it's asking me what are the dimensions of the cross section on this right rectangular prism. So I can see this prism is being sliced this way vertically. So the dimensions they're asking for the dimensions of this rectangle that it made. So what I'm going to do is I know this is one side of the rectangle, and I'm going to go over to the shape and see that's the same as this side of the prism. So I know one of the dimensions is 4 inches. Then I'm going to do the top part of my rectangle here and say, okay, and I'm going to go over, it would be the same as this one. What dimension would that side be? Well, if I'm not sure, I can go to the bottom of my rectangle. It's the same size. So that means it would be the same as here too. So it's 4 inches by 2 inches. Remember, this is a two-dimensional shape, so you should have 2 dimensions, 2 numbers to represent it. So in number 8, they don't draw the picture for us. They just call it the vertical cross section. So a vertical cross section, vertical means up and down. I remember because horizontal is the opposite. So horizontal is like the horizon, that's going to be flat, straight across, and vertical is up and down. So the vertical cross section means and it makes sense because normally when we slice butter, we would slice it here, slice right down like this. So that's the cross section he's making. So that's going to create a rectangle, and I just need to know, it says describe. So describe means that you would tell the shape, so it's going to be a rectangle. And if we want to be even more specific, then we can say, well, that rectangle would be, since it's sliced this way, it's going to be 3 inches by, and then how long is this side here? So I have to kind of go over to my shape. That would be the same as this dimension, which is the same as this dimension, 2.5. So I know that's going to be a rectangle that is 3 inches by 2.5 inches. Then looking at number 9, It says, what are the dimensions of this vertical cross-section? So the vertical cross-section is already shown for us. It's this green face, and you can see that it's a rectangle. So the first dimension is the longest side of the rectangle, of the rectangular prism. So that would be 9 feet. And then the other dimension is going down. So I have to look over to my shape and think, okay, this dimension here is the same as this length, which is the same as this length. So it's 9 feet by 3 feet. So that's the vertical one, the one that slices down. Part B says, then what would the horizontal cross-section be? So to answer that question, I'm going to, if they didn't cut it for me, but I can imagine that. I can imagine slicing it, that I slice it this way, I'm going to cut right through it, like that. So that would make a rectangle. I make a rectangle like this. That looks like a parallelogram, but I'm drawing it like as if it's, from perspective here. So I start with this dimension, and I look on the shape. Okay, that's the same as this dimension here, which is the same as this dimension here. Those aren't labeled, so I'm going to walk around the shape until I get the same length, 5 feet. Means this must be 5 feet. And then this side dimension here, right here, I'll look down and say that's the same as this length here, so that's by 9 feet. So that means you get a rectangle that is 5 by 9. So there's three questions that kind of deal with dimensions and cross sections. Number 10 will be the last one that we'll do then. So number 10, describe the cross section shown. So you can see it's a rectangle, and then the dimensions would be, so this is one side of the rectangle, so that's 6 feet. And then the other dimension is over here, and it's the same as the 11 feet on the figure. It says, is it possible for a horizontal cross-section with different dimensions if you have a plane intersect the prism at another height? So that seems like a confusing question. What it means is if this green rectangle sliced higher on the rectangular prism, like let's say instead of cutting where it does, let's say the green rectangle sliced up here and went straight across, or if it sliced down here at the bottom and went straight across, would that give you a different cross section? And the answer is no, because as long as it's parallel to the base, as long as it's cutting straight, as a horizontal cut, you're going to get the same rectangle as the base, essentially, or as the top. So the answer is no, because it will be the same shape and size. All right, so there's a couple examples. The next thing that you will do after this is the Math Excel practice.